Good afternoon everyone. আজকে ক্লাস হলো আমাদের ম্যাটেরিয়াল সিলেকশন নিয়েই ম্যাটেরিয়াল সিলেকশনের পার্ট কি ফ্যাক্টর অফ সেফটি সম্বন্ধে সো in this class we learn about how we can use it and what is the industrial rule followed by the companies. So what does they do and how the material property can alter with which is dependent on temperature, depending on temperature or something or rather than any other factors. So in today's class we at first we will go with the simple definition or something what we know that about factor of safety. So factor of safety is a simple definition where we consider maximum allowable stress by working stress. Now this is what comes where we consider in terms of material. As I have told you in the earlier class, am I audible?
Yes, sir.
So as I've told you in the earlier class that this factor of safety is nothing but a mathematical tool. I'll briefing this one that I'm briefing right now. This is a mathematical tool to understand how the stress is working, how much percentage of how material is behaving according to the applied loading. So this is what factor of safety teaches. Now this is we could understand or we could project from the number. If it is number 1, if the factor of safety is 1, that means the allowable stress and the working stress are now and then same. If the factor, if the allowable stress is in higher number, that is the factor of safety is 2, and that means that the allowable stress is 2 times more than working stress. That makes a sense from here. That makes a sense because we will not like to have similar stress. That means we will not like to have a similar amount of stress or similar allowable stress quantity for the working stress. Now is that clear to you all that have you got? Let me shall I explain in bit details? Shall I explain in bit details? Shall I? Yes.
Which
Details factor of safety, which will make you but details in a simple way that will make you very easy to understand. So let me make one thing for you. Let me make one simple expression for you people. So let me stop presentation and let me go for window and enter screen. So what I'll be showing you right now is the paint visible to you people? Okay, so I'll let me tell you someone has arrived, I think so. So let me tell you something that I will ask this type of conceptual question, that what is the significance of factor of safety? Is it a physical phenomenon or it's only a mathematical or theoretical way out to understand? So this type of questions will be there. So let me make you one thing understand. Now suppose, let me consider a red line. Okay. And another line to be a black. Oh, sorry. Now just try to understand. Let one be the load line, one be the or you may say that this is the mathematical way out to understand. So this is my way. This is the simplest way I could make you explain. this is, suppose this black line may be your allowable stress, and the red one is working stress. And here it's 0. Everything is starting from 0. Suppose it's starting from 0. Now why I am making this? Because it will make you understand it in easy way. Now, so this black arrowed line shows the intensity of the stress. Okay, am I clear to you people? This black arrowed line tells about your the amount of allowable stress, and this working stress is this red color line is the working stress. Now this the more the length, the more the intensity. Okay, let us assume that if the length of the black color line is more, that means the intensity of allowable stress will be more. So now let us come to some basics for you to understand. Now what will happen if both of the intensities are same? Both of the intensities are same. It will give you, number one, it will give you a factor of safety of 1. Fine. If the factor is same. Now what does that mean? What does that mean? That means let us understand in a simpler way. If the working stress is always same to is completely same as allowable stress, so what can happen? Can anyone tell me what can happen if it is entirely same? If the intensity of both
যদি কোনো এক্সট্রা স্ট্রেস যদি হয় তাহলে ভেঙে যেতে পারে জিনিসটা।
Yes, exactly, correct. That means there is a chance of breaking. So what we do as a condition. Fine. Now let's go for the second one. Second one is if factor of safety is equals to 2. Then what does that mean? Let us delete the line. I'll be doing for you people. Let me delete the line. Fine. So, and now tell me, allowable stress intensity line is bigger than the working stress intensity line. So is it favorable to use? Yes or no? Is it favorable to use?
Yes.
That means yes, it's favorable. Fine. Okay. Next, the third point, which comes which from where we learn from the rule of third. Fine. This is factors of safety is equals to 3. Now what does that mean? What does that mean? That means the let me short the line much more. It will be late. Just a sec. Give me a moment. Fine. If the factor of safety is FOS is equals to 3, then what does that means? That means the working stress is 3 times lesser than the allowable stress. Am I right? That means it's more favorable. my maybe the spelling may be wrong now. Why I'm telling you about this? Why I'm telling about this? Why this said that a factor of safety after 3, that means from 3 to the maximum what limit you can take, is the most desirable, is the most desirable in condition. Now you may say that, sir, we have not seen the book or something. This is the industry standard for you people. This is you should know, this is the industry standard. So why is it why it is done so that any design what we,
কোনটা স্যার 30%?
yes, that means 30%, correct, that means 30%, that is termed as rule of third. The in few company it is an unsaid rule. So why I'm telling this, because you will be knowing about it, you will be very much that will make you a sense how it works actually. That will give you more favorable conditions, how designs are drawn, how designs are made in industry. So let me come to the point. So 30%, why the 30%, or 3 why factor rule of third, or one, in some companies it is said a rule of 1/3. So this is the same, now and then it's the same things only. Now so the name has been changed because you cannot say keep the same name, but this is the unsaid industrial rule. What does that means? That means if the working stress is if working stress W point S is equals to 10 kilonewton per millimeter square, then the allowable stress will be minimum, that is the minimum, very minimum, 30 kilonewton per millimeter square. This is the industry standard. I'm repeating again, these are the industry standard which is maintained by the whole industry standard, STANDARD, industry standard. This is the industry standard which is maintained by entire industry and entire world. So you have to, in every country we use, but in every in industry we use, most of the industry, some industry doesn't use, they compromise with this one. Why? How? It's a standard which makes them 3 times safer for design. Now here comes the point, what to do if the cost of industry from why it is 3, after before that why it is 3, why not 2, why not 4, why it is termed as rule of third? Can anyone answer me that? Why it is rule of third or rule of 1/3? What is the main reason behind it? Can anyone answer it?
যদি খুব বেশি যদি সেফটি মার্জিনটা বাড়ে থাকে তাহলে কস্ট অফ মেটেরিয়াল বাড়তে পারে, সেই জন্য আমি আর বেশি করি না।
3 কেন? 3ই কেন? 3 কেন? why 3?
না জানি না
স্যার 3 এর বেশি গেলে তো আই গেস মানে ওয়ার্কিং স্ট্রেসটা খুবই ছোট হয়ে যাবে, তখন সেটাকে কনসিডার মানে ইন্ডাস্ট্রি লেভেলে সেটাকে কনসিডার করাটা কি সেটাই।
এটা এয়ারক্রাফটের ওয়ার্কিং স্ট্রেস কত থাকে সেটা জানো? মানে ওয়ার্কিং স্ট্রেস মানে ফ্যাক্টর অফ সেফটি কত থাকে জানো একটা এয়ারক্রাফটে? ছোট্ট আমাদের যে বোয়িং 737 ইউজ করা হয় কিংবা এয়ারবাস A320 ইউজ করা হয়, মানে এয়ারবাস, তো এরা কত ফ্যাক্টর অফ সেফটি রাখে? তোমাদের কোনো ইমাজিনেশন আছে কত সেফটি? স্ট্যাটিক লোডে, ফ্লাকচুয়েটিং লোডে কথা বলছি না, কিন্তু স্ট্যাটিক লোডে কত রাখে?
না নেই
60। এর জন্যই একটা প্লেনের দাম $300 মিলিয়ন, তারও বেশি হয়। তো এই জন্যই আমাদের কথাটা যে এত বড় একটা মেশিন নেই, আমরা এত ফ্যাক্টর সেফটি থাকে না। এখন যে তুমি এখন বলতে পারো কিছু কোম্পানিসরা ম্যাটেরিয়াল নিয়ে কম্প্রোমাইজ করে না, কিছু কোম্পানি করে 100%। ও যে কে জানি বললো কথাটা, যেই বললো কথা, আমরা অনেক সময় আমরা অনেক কোম্পানিরা করে যে ওয়ার্কিং স্ট্রেস এত ছোট, এত বড় ডিফারেন্স নেওয়ার কোনো মানে হয় না, আমরা সেই জিনিসটা বলি। So what some industries does that, they think that it is very the working stress is so small, so why shall I take so much greater margin of for allowable stress, that doesn't make any sense, that is very costly, will not so go. But it actually makes a sense because it's all about safety. Now let me come to the point. Okay, let me come to the point. Let me draw one graph. Now tell me one thing, which point among which point is your yield stress in brittle material? Can anyone tell me? Can anyone tell me where is the brittle material yield stress point? Does anyone knows where it is?
যেখানে কার্ভটা হচ্ছে ওই ইনটা দিতে হবে, ওই যেখানে একটা কার্ভটা
আর ওই
হচ্ছে
নেক
ওই জায়গায়
ফরমেশন,
স্টার্ট হচ্ছে ওখান থেকে
নেক ফরমেশনের পয়েন্টটা যেখান থেকে নেক ফর্ম করবে।
এখানে নেক ফর্মেশনের কোনো গল্পই নেই ও ইয়েতে, there is no such story of neck formation in brittle material. Neck is
স্ট্রেট
in ductile material.
লাইন স্টার্ট হচ্ছে না বা এটার সাথে, ওইখান থেকে যেখান থেকে কার্ভটা যেখানটা একটু বেঁকেছে ওইটা তো।
This is not the way for brittle material. Why? Brittle doesn't have any necking or necking effect or anything like that. Okay, so what is the way out to what is the way out to do this one? So there are a lot of the simple way out is this, that just you should know about this thing. What we do is that we do a shortcut method. We draw a line or a tangent at the corner. Okay, at this one. So we take the slope and when we go for another line, with the offset of 0.02 to 0.03, that is 2% to 3% offset. So what we do is in very simple word, in very simple word, what we get is that we get our difference over here. This gives our
কি হলো স্যার বুঝলাম না,
হ্যাঁ কি বুঝলে না বলো।
কি করে ড্রটা করলেন, সেকেন্ড লাইনটা কি করে ড্র করলেন?
Okay, first we take one tangent. Okay, we take one tangent because it's in practical it's a tangent. We take one tangent, then what we draw a parallel line taking 2% of 2% of line, 2% of deflection, or what we say, how shall I give the
মানে এক্স অ্যাক্সিসে 2% বেশি সরে গেছে তো।
কারেক্ট, কিন্তু এটাকে একটা ওয়ার্ড দিতে হয়। তোমরা পড়েছিলে ম্যাটেরিয়াল সায়েন্সে পড়িয়েছিল এই পার্টটা, ক্রিপ?
না না
No, okay, fine. So let me tell you, it is just a parallel line is made with 2% more x-axis deflection. Fine. This is done by 2%. That means what happens is that, to be very specific, so what is we find out the stress over here. Like there can be a stress, let any stress, let x amount of stress. So we go for 2% or 3% stress. That is the stress will be having x plus 2% of x, 2 or 3 or 3, anything. Is that clear? Is that clear or not? আই এম গিভিং ইউ সিম্পলেস্ট ওয়ে আউট অফ। বুঝতে পেরেছো কি বুঝতে পারোনি? কি করে আমি আবার বাংলায় বলছি, এই এক্স যদি স্ট্রেস হয়, এক্স অ্যামাউন্ট অফ স্ট্রেসের 2% কিংবা 3% স্ট্রেসের সঙ্গে অ্যাড করে যে ভ্যালুটা আসে, সে ভ্যালুটাই আমরা এখানে এই ভ্যালুটাকে আমরা বলি ইল্ড স্ট্রেস। কথাটা বোঝা গেছে? It is only valid for brittle material. It is only valid for brittle material. It is not valid for ductile material. Please keep this in your mind. This is valid for only brittle material, because brittle material doesn't have any sort of necking. There is no sort of necking in brittle material. So we could theoretically say that the yield stress is at the 2% to 3% of the this tangential point. Clear? সবাই বোঝা গেছে? আচ্ছা, এনি
স্যার যদি এটা ডাক্টাইল হতো তাহলে কোন পয়েন্টটা হতো? এই কার্ভের জায়গায় নাকি একদম এন্ডে গিয়ে?
ductile is having a other phenomena. Ductile automatically gives, you don't have to calculate. The thing
মানে ওটা কোন জায়গাটা?
okay, fine. Don't worry, I'm done. Let it be sigma, let it be this one, this is the stress. So the stress and strain for ductile material, it will be like this. Now there are some certain point. Let me give you the let me give everyone this points. You should always remember these points. Okay, no, not an issue. Now let me give you one simple idea to understand. This is for ductile, ductile. Now because it's a because this point of understanding here, you have to be very cautious regarding this. Now this point, let me get this one. This point is termed as, this is termed as limit of proportional limit. But it depends on this term is in proportional limit in some books. So you cannot consider this as your yield stress. Now this is the where comes your yield stress. This is termed as UYS. Now everyone, if you have book, if you have pen and pencil, just write. It is termed as upper yield stress. That means from this point there is a crack generation. The crack generation starts for the this is the where the crack starts to generate. This where we start to have the crack, the internal crack, as I have showed you in the day 1 of your class. From where you get the crack. This point is your lower yield stress. Now what does lower yield stress means? That means that means the necking has been formed. So in this area the necking starts. This means that the execution of necking starts from B to C, which get extended till D. D is your ultimate stress. So what happens is that from C to D, the diameter of the specimen, or the diameter of the diameter, I shall not say the diameter, the cross section gets smaller, and the diameter, the cross section gets smaller and smaller. So due to the necking effect, so what happened after that? It fails over here. This E point is termed as fatigue stress. Now here comes one more point why I have given the A. Before that I'll tell you, because there is a one significance why to give the A, because this gives a practical significance. That's why I have given here A. So I'll be coming on right now only, but before that, if anyone have any confusion regarding this graph, please ask me. Any confusion? Any confusion?
না
কোনো confusion নেই. Now why I have given you A? What is the main purpose of it? Now you may ask me, I have told about even here I say the proportionality limit. Proportionality limit. Now we know that there are two sections in any of the stress strain diagram of ductile material. So this is the plastic region, this is the elastic region, and this is the plastic region. So this so what we know that if there is any deformation, so in the body, that could be revived, or that could go that could attain the old shape. But in plastic deformation, the deformation cannot be altered. It cannot go to the same state as it was. So this is the thing what comes in your brain. But would you like to initiate any small amount of crack while loading? My first question is that if you are asked to design a object, and if you are loading till upper limit stress, that means the point from where the necking starts, that means from there the deformation is going to be a plastic deformation. So do you want to push your body or your object to have a plastic deformation, or the start plastic deformation? Do you like to have that? Do you like to have that?
না
No, you will not love to have that. So what will you do? You have to stop somewhere else. The stopping point is here. Let me change the color. The stopping point is here, the A point, where we say that proportionality limit. Understood? Is it everyone? Yes or no? I'm not getting a response today. So is it clear to you people?
হুম
অন্যরা কি বুঝতে পেরেছো কি বুঝতে পারোনি? বুঝতে পেরেছো?
Yes,
Yes,
sir.
sir.
Okay.
Okay.
So this makes the sense where now you may say that, sir, in some books it's not written there. I could bet on you that books are meant to read. So there are some practical things what we go inside. So in practical books you will not find it, because there are practical thinking you have to go, because design is not theory, or it's not related to book that it is written over here and it will happen. No, you have to use your common sense. You have to use something like you have to give some boundaries. You have to understand, shall I go with that or shall I not go with that? So here comes your point. Now this is the point where I'll be stopping, and I'll be going for the next topic. Now the next topic comes okay. So is the PPT visible to you people? Yes or no? Can you see this?
হুম
Yes, sir.
ইয়েস স্যার
Okay. Now can you see the third? I'll not go for P strain or the engineering strain, so I'll come after that, but I'll be showing you one more thing for which we have to consider the distortion energy or impact energy, what we've studied in our solid mechanics. Now have you thought about, can a material a brittle material is a ductile material, and a ductile material can be a brittle material? Can it be interchanged? Can it be interchanged in practical world?
মানে বুঝলাম না
Can the property of a material, of ductile property of a material, can be altered to have a brittle material? And same goes for the, can the brittle property of a material can be which can be shifted to ductile material? Is it possible? Is it
হ্যাঁ যদি
possible?
মেটেরিয়াল প্রপার্টি চেঞ্জ করে দেওয়া যায় তাহলে তো হতেই পারে
হ্যাঁ, কি বলছো বলো?
মানে যদি মেটেরিয়ালের প্রপার্টি যদি কিছুভাবে চেঞ্জ করে দেওয়া হয়, মানে বন্ডসগুলোকে যদি উইক করে দেওয়া হয়,
How
তাহলে
to do
সেটা
that?
হতে পারে
How to do that?
অন্য কোনো অ্যাটমস মানে ইন্ট্রোডিউস করে
See, there are two ways to correct. Correct. There are two ways to do that. Let me come for one simple way. One is using radiation. huge amount
কি
radiation.
ও রেডিয়েশন আচ্ছা
Like how many of you heard of Chernobyl?
Chernobyl disaster
Chernobyl disaster. There is a big elephant foot. That is nothing but the raw material or the residue of that what to say of that explosion. Fine. So what is happening is that the bed of this Chernobyl, the concrete building, the concrete as well as the concrete as well as the metallic structure is losing their property. So they are losing their property because of constant bombarding of the corium, sorry, not chromium, corium, constant bombarding of corium. Now you may say, what does that means? That means that what is that they are breaking the bonds, and that are changing the property of the material around surrounding it. So that's why scientists are they are very much scared about what will happen if the entire thing melts down and goes to the bed water level. So what will happen? So that's what they are thinking. Now you will say, what is the significance of relative to this one? Now here comes the point. The point is that, as we know that the material ductile material and brittle material is nothing but the property of a material, mechanical property of a material. So what happens is that when you apply a certain energy, as I have told you, by radiation, the practical example, and the second part is by applying the temperature. What happens is that when we apply temperature in higher range or lower range, so what happens is that in some cases we have seen that a ductile material at a very lower range, it becomes brittle, and in some cases we have seen that brittle material at higher temperature, it becomes ductile. So you may say that, why is it you may ask me, sir, it will not work as a pure ductile material. Yes, correct, it will not work as a pure ductile material, but you can find some ductility property at that point. So there, what do I mean is that the transition temperature is the main point where from where the property can alter, from where you can alter the temperature, the property of the material. Now here comes the point. This is in mathematically we say that it is related to hysteresis curve. How many of you know about hysteresis curve? জানো কি hysteresis curve?
ম্যাগনেটিজমে পড়ানো হয়েছিল
Correct. This works like that only, that curve itself. So a material can go from brittle to ductile, again it can come from ductile to brittle. So everything is possible, you cannot say that you cannot say this is feasible, this will be entirely ductile and entirely brittle. There is no such material that is purely brittle and purely ductile. It's a myth, it's an ideal condition, and it's not possible. Now coming to the practical, because I have told you design is all about practical. So what we come is that pre-strains and engineering strains. Now there are a lot of things. What we do is that this is all about analysis. Let me get my pointer. Laser pointer. So as you can see, can you see my laser pointer? Is it visible to you? Is it visible to you? Now in laser, as I can show you that there are a lot of types of same material which is showing a difference in strain as per the temperatures. Now you may say that why is it showing so? Because as you have told that, as you people only have told that if I apply some energy, now the energy can be any energy, like as I have told you, that could be a radiation, that could be your your heat, direct heat, that could be a radiation. So basically two, there are lots of that, but I'm just considering two of them. So what happens is that according to temperature, there's a bonding issues, that is the chemical bondings. So what happens is that the strain also, the parameters of the strain also changes. Now as you can see, the strain at minus 60 degree is higher. That means it is having a long range of strain. That means it will not break. The fatigue point is far away. But if you apply a 100 degree centigrade, the failure point is nearby. That means this is what I want to mean, that this is about a ductile material. So this is what I mean, that the temperature makes an effect. Temperature can do anything what you want, anything what he or she likes. The temperatures can do. Temperature can do. Now about that, here I come with a new principle that is termed as pre-strain. You should know about it. Pre-strain. Now to understand pre-strain, you have to understand the strain hardening process. How many of you know about strain hardening process? Have you heard about the word strain hardening? Strain hardening?
No.
No one of you heard. Now I'll be going with this in the next today itself. Now before that, let me go for the strain hardening, the last topic, and this will give you a vast experience about this one. Now in the previous class, in the first class, I've showed you something like this. Let me put some colors. Fine. So do you remember this one, this story, as I have told everyone? Do you remember, you people, do you remember this? I told you in the first class. So there I have told you about how crack develops, and this. Now I'll tell you how crack makes material more harder. Can you imagine that could also happen? Yes, that happened. That happens. But the thing is that you have to understand, there should be some parameters. There should be some. There are a lot of things to be gone inside. So I'll just show you one factor that is termed as your hardening. That is your strain hardening, which will give you an example, which will give you a knowledge about what is pre-strain and what does it happens. Now let us understand first the word. What do you mean by pre-strain? What do you mean by pre-strain? We know pre-strain is nothing but the strain, the amount of strain it is already having. Okay, fine. This is the amount of strain which it is already having. So you cannot alter that. You cannot do anything with that because it's a pre-strain. It is having that pre-strain. Now what does that means about what it makes a role about it? So as I have told you, after while loading, that means the amount of strain get increased. Fine. I'm applying a load and the amount of strain is increasing. So that means what is happening? The amount of strain is increasing. Now what you did is, you people did one thing, that you stopped providing the loading. That means you have stopped the loading. That means it was under loading. You stopped the loading. What will happen? Can anyone answer me? What will happen if you stop a loading? মানে শর্টে বলছি, একটা বডিকে তুমি ফোর্স অ্যাপ্লাই করছো, তারপর অ্যাপ্লাই করতে করতে একটা টাইম ফোর্স অ্যাপ্লাই করছো, তুমি জানো এটা 10 ঘন্টায় ভাঙবে, বাট হোয়াট ইউ ডিড ইজ ইউ স্টপ দ্য লোডিং at 5 hours. What will happen? what
অরিজিনাল সাইজটা রিগেন করবে।
sorry
যদি লোডটাকে হাঁটিয়ে দিই অরিজিনাল যেরকম শেপ ছিল এরকম রিটার্ন করতে চাইবে।
correct, it will try to go to its original state. That means it will try to go to its this one, this state. But this is not the practical. What happens is that what we have seen, it practical thing, what we have seen that it goes to this way. Now what happens is that after removing the load, you will find at least this one, you will find at least this one of this amount of strain. Why it is happening? After that, when you again apply load, you need the fatigue stress or the fatigue load will be more than the previous. Is it clear to you people or not?
লসের সাথে কোরিলেট করতে পারলাম না।
মানে আগে এটা যদি কনস্ট্যান্ট লোডিং করতাম, মনে করো আমি এটাকে যদি কনস্ট্যান্ট লোডিং করতাম, মনে করো ওই 10 আওয়ার্স ধরে লোডিং করতাম, যেই স্ট্রেন ফেটিক লোডিং হওয়ার কথা ছিল, ফেটিক স্ট্রেস হওয়ার কথা ছিল, তার থেকে বেশি হয়ে যাবে যখন তুমি এটাকে লোডটাকে 5 আওয়ার্সে আনলোড করে আবার লোডিং করছো। কথাটা বোঝা গেছে?
আচ্ছা, মানে বেটার হয়ে যাচ্ছে কোয়ালিটিটা।
এক্স্যাক্টলি।
স্ট্রং হচ্ছে।
Why is it happening? Because you people only told me that one thing, that the material tries to recrystallize or what the material properties changes due to temperature. Here the same thing happens. What happens is that when you are applying a force, nothing but there are micro thermal stresses, there are micro residual stresses. What happens? This generates a thermal stress. Always remember that generates a thermal stress on the point or the intersection points of where strain is generated. Now what is happening as well as in the boundaries? So what happens when you remove the stress? That means they are going for a heat treatment process, that is micro heat treatment process. What makes that makes the strain more stronger, and that makes the strain more stable. That means that get hardened. Clear or not? বোঝা গেছে কি বোঝা যায়নি? বাংলায় আবার বলছি,
যে কোনো মেটেরিয়ালকে আমি পাবো সেগুলোকে আমি টান মারবো কিছু দিয়ে, নিয়ে তাও একটুখানি গরম করে নেবো, ঠান্ডা করলে এটা তো প্রপার্টি দিলে আরো শক্ত হয়ে যাবে।
এক্স্যাক্টলি, ওটা করা যেতে পারে। এটা না করলে তুমি গরম না হিট না দিলেও হবে। আমি কি বললাম? ইন্টারনাল মাইক্রো থার্মাল হিটিং। ওটা ডিউ টু দ্য অ্যাপ্লাইড ফোর্সে গ্রেইন বাউন্ডারিতে হয়। ঠিক আছে, এই যে গ্রেইন বাউন্ডারি, এই কালো বাউন্ডারিগুলো দেখছো, এর মধ্যে এই জিনিসটাকে আমরা দেখতে পাই, এই জিনিসটাকে দেখতে পাই। সো হোয়াট হ্যাপেন্স? this phenomenon, due to this phenomenon, the material get again recrystallized. কথাটা বোঝা গেছে কি বোঝা যায়নি? আবার recrystallization হয়ে যায়। There is a micro recrystallization. That is all about micro. There is no anything macro. This is all about you people. Let me tell you, this is all about chemical things. What material science is nothing but it's a part of, it grants majority of parts from the chemical engineering. So this is what happens. যেখানে আমরা বুঝে যাই যে that means there is a recrystallization process, micro recrystallization process, which refines the material and the material get more stronger, for which the fatigue stress after in the second condition gets more is more than the previous condition. Clear?
সেটা কি অ্যাকচুয়ালি ইন্ডাস্ট্রিয়াল ইউজ হয় এই প্রসেসটা?
এটা দেখা ইন্ডাস্ট্রিয়াল ইউজ না, এই প্রসেসটা আমরা করে থাকি, সবসময় করি না, এটা দেখে নিই আমরা, এটা জানি এটা হবে, তার জন্য তো ফ্যাক্টর অফ সেফটি আমরা 3 রাখি। দ্যাটস ওয়াই উই কিপ এ ফ্যাক্টর অফ সেফটি 3. If there is a problem in internal recrystallization, that's why I was coming in the point. If there is a recrystallization, internal recrystallization, there is a flaw in the internal recrystallization, that means the material can break down. The property of the grain boundary can change. So that's why we always try to have 3 times more stress, more allowable stress, 3 times more allowable stress rather than the previous one. Got my point?
আচ্ছা, মানে এই প্রসেসটা যেটা আপনি দেখালেন এটা শিওরলি বলা যায় না, মানে আউটকামটা কিরকম হবে, বাট যদি স্ট্রং হয় তাহলে এই প্রসেসে স্ট্রংটা হয়,
হতেই পারে,
তাই তো?
হ্যাঁ। এখন একটা জিনিসটা বোঝো, একটা বডি 30 ইয়ার্স ধরে কাজ করছে, মনে করো একটা ম্যাটেরিয়াল পার্ট একটু 30 ইয়ার্স ধরে কাজ করছে। সো ইট গ্রেন বাউন্ডারিগুলো হবেটা কি, গ্রেন বাউন্ডারিতে আস্তে আস্তে সব দিকে ক্র্যাক ফর্মেশন হবে, আফটার ক্র্যাক ফর্মেশন হবে এরকম করে একটা, সরি প্রত্যেকটা গ্রেন বাউন্ডারিতে আস্তে আস্তে ক্র্যাক ফর্মেশন হবে, আবার ইন্টারনাল ক্র্যাক হবে, কারণ কি ইট ইজ ওয়ার্কিং ফর লং 30 ইয়ার্স। There will be a crack formation, internal crack, which you cannot see with naked eyes. That's why for maximum safety we do a 3 times more. This is industry standard.
না, কিন্তু এই ইন্টারনাল ক্র্যাক ফর্মেশনের জন্য তো আপনি বললেন যে মেটেরিয়ালটা আরো স্ট্রং হয়ে যাবে।
হবে, তবে অনেক জায়গায় স্ট্রং নাই হতে পারে।
আচ্ছা, ওটা শিওর না।
Uncertainty, there are lots of uncertainty. অনেক
আনসার্টেনিটি কি, এই আনসার্টেনিটিটা কি মানে মেটেরিয়াল টু মেটেরিয়াল মানে ভেরি করে। সাপোজ ধরুন স্টিলের জন্য এটা আমি জানি যে শিওরলি এটা স্ট্রং হবে, আবার কপারের জন্য আমি জানি না, এরকম কি ব্যাপারটা হচ্ছে জিনিসটা?
কারেক্ট। এখন যদি বাইমেটাল হয়, ইফ ইটস অ্যান অ্যালয়, it will behave something like that. So we cannot say I mean you cannot confirmly say that it will work like this. It is not linear for every material. So you have the মানে প্রত্যেক there is a change for every material. তুমি এটাকে বলতে পারবে না যে এই ম্যাটেরিয়ালটা এরকম বিহেভ করছে, এর জন্য কপার অন্যরকম বিহেভ করবে, আর টাইটানিয়াম এরকম বিহেভ করবে। there is no relation. কে কীরকম ভাবে হয়েছে, কার কীরকম ম্যাটেরিয়াল কি কন্ডিশনে কাজ করছে, তার লং ওয়ার্কিং লাইফ কি, সেটার উপর ডিপেন্ড করবে। ঠিক আছে, বোঝা গেছে? কারো কোনো কোশ্চেন? এনি কোশ্চেন? কোনো কোশ্চেন আছে কারো? হ্যাঁ, কারো কোনো কোশ্চেন আছে কি? না কি আমি শুধু
না স্যার,
বোঝা গেছে আজকের পার্টটা? মানে এখনো আমরা নেক্সট পার্টে আমরা ড্রয়িংও করব, আমরা করব, একটু থিওরি পার্টটাও দেখবো। বোঝা গেছে ব্যাপারটা আমাদের কেন হাওড়া ব্রিজে ফ্যাক্টর অফ সেফটি নিয়ার অ্যাবাউট 100, why it is near about 100 and why it is stand still till now. The reason is only these are the small reasons. There are lots of reasons behind it, but these are the small reasons which makes for which we try to have the much more feasible amount of factor of safety, the maximum feasible amount of factor of safety. বোঝা গেছে সবার? ক্লিয়ার? ক্লিয়ার? তোমাদের আওয়াজ এত কমে গেছে কেন? বোঝা গেছে কি বোঝা যায়নি? আচ্ছা 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 আজকে একটা মডিউল, মানে প্রথম মডিউলটা বেশি কিছু নেই, সেকেন্ড মডিউল থেকে অ্যাকচুয়ালি ঘটনাটা আমরা শুরু করব। Now I'll be going for the second chapter. Before that I'll be telling you about one more factor about it. Now you may ask me, sir, why will be telling this one that it's the validation depends on the type of loading and everything. Now what I have told you just before that about the strain hardening, about the pre-stress, the thing is that it is all valid. It is all valid. It all happens. But the thing is that there is one more thing addition to it, which makes everything worse. Every design you have to be very much. You will be finding the design to be the worst quality of design. It happens because it's not a fault of designer. It's not fault of the manufacturing. So yeah, because there is a lot of uncertainty. So let me tell you one story, small story. The story is that about India and US. What do you do in India? what do we do? If we buy a car, for example, we bought a car of a car right now. So for how many years will you make this car to run? For how many years you use the car? For how many years? কত বছর ধরে গাড়িটাকে ইউজ করবে? For how many years?
maximum 10 to 15.
Is it practical? Regarding India, I'm not telling about US. I need everyone's answer. How much older car you
5 বছর
can?
তো পুরোনো গাড়ি সেকেন্ড হ্যান্ডে বিক্রি হয়।
Exactly. তাহলে এখানে তুমি আনসারটা বলে দিলে। That means we use a car still till the engine rips off or the engine doesn't works completely. This is India. Though it's because of our economy, so I'll not go for any other thing of other way. So we use the car till the engines break down completely. Fine. But what happens in other countries, other developed countries? The car get reused, or not reused, they buy a new car after again certain years, like 10 years, 15 years or 20 years of 10-year period. So what happens is that they know that after 20 years the car will not behave like this, the fuel efficiency will come down, so they actually stop the car using this, actually stop this car, and by with exchange of that they bring the car. Now let me give you one example. One car in my family. I have a car of Maruti 800 first model. Do you remember the Maruti 800 of first model? That is of 1990. The story is there that still it is working in my home. Why? My uncle is still driving the car. Why? Because the car engine is still okay. But if you bring this happens, similar things goes to US, they will not do the same. They will just reuse, they will stop the car, they will exchange or do the car. Why? They will get a new car due to fuel, there may be other issues, something like that. Now what is the main problem with that? The main problem is that what we have studied and what we are studying right now is all about static loading. We are not considering the fluctuating loading, because fluctuating load is the most vulnerable thing of engineering mechanics, of engineering design. We don't understand the behavior, how fluctuation works. Now let us give you one small example, and I'll wind up and I'll go for the next one. Can you see this one? This diagram, a shaft is getting bent. That means there is some bending stress, whereas for which I am getting one graph. Can you see this one? Is it visible to you people?
Yes, sir.
So what that means? That means every particles of any components, or you consider a car, a Maruti 800, it is having 1 lakh parts. 1 lakh, considering a small screw to a complete engine section or a complete chassis. So entirely it's near about 1 lakh. So what does that means? That means that every point have their own amplitude, every point have their own fluctuating load, regardless of the static loading. Because static loading, we know that there is a static loading, but if we don't consider the static loading also, then also we are having this type of loading. We get this type of loading, and we don't have any way out how to solve it. So for that, what we do, I'll be going a short, because I will be showing in the next class. There are 3 scientists. Can you see the name of the scientist? Garber, Goodman, Soderbergh. Can you see that? Can you see?
Yes, sir.
So this is what comes in the issues, and that made the entire industry to change the material, that make the industry to understand that we are why I have told you that we consider, we always try to consider the yield stress, the why is the reason behind it, what made the maximum problem. So you may ask me that from what the curve has been generated. The curve has been generated by numerous number of practices, that is numerous number of trial methods which gave the result, and according to that we have done this one. Fine, I'll be coming on the next half of the class. So in the next half of the class we'll be starting about this one, fluctuating load, from where we'll be getting the sums, mathematical terminology by the using of logarithms and everything. This is from where the design starts actually in practical world. Now you may say that sir, what was about previous class? Those are the theory what we maintain, because this is also having a practical impedance. But the thing is that over here from the second half we'll be getting about how practically it works and how practically in mathematical terms, that was on theoretical terms, and this is on practical on mathematical terms, how you can relate with the practical world. And we'll be getting to this. We'll be designing joints, we'll be designing about the types of shaft, how to design a shaft, we'll learn about it. There are lots of sums in the coming classes. So we'll see at 3 p.m. Till then I will see at you people at 3 p.m. okay. Now as I was telling you that we'll be proceeding for our next session, that where we'll be learning about that what we have learned till today, that is the static loading, and but this is not the reality. We have to consider the our other thing like the fluctuating loads also. Now before starting I'll give you one practical knowledge regarding this. I'll show you something, because showing that will give you a more significant idea how much it is dangerous. Okay. Am I audible? Okay. Now I'll show you something how much a fluctuating load is very dangerous, because there is a video over here. Now I'll be telling you something regarding this also. Okay, fine. Let me start the video. Okay. Can everyone see the? Okay, fine. I have not shared the screen itself only. Sorry for this one. So okay, this is one of the 777 aircraft which was caught on air, caught fire while it was during cruising. Now what I am here to show you that how vibration is very much dangerous, to what it can affect and what it can do. Fine, let us see what happens. See, can you see the amount of vibration, that is the what is happening over there? Can you see? Is it clear to you?
ভাইব্রেশন কি করে বুঝছি?
ওই দেখো ইঞ্জিনটা নিজের অ্যাক্সিসের থেকে নড়ছে, দেখতে পাচ্ছ? মানে ও একটা থেকে রেসিপ্রোকেট করছে, ইট ইজ রেসিপ্রোকেটিং। ক্যান ইউ সি দ্যাট?
Yes, sir.
Okay, now why I am telling you about this? Now try to understand the wing is is attached to the engine is attached to the wing at with some with a overhanging beam. So what happens is that due to the vibration of this body, what happens is of engine, there is an effect on the aircraft. So what will happen if the vibration is out of control? So if there is any point of break, or any point where there is a problem, or there is a crack, internal crack can propagate. Is that clear to you, that how much engine stress, how much a fluctuating load can be dangerous? Now, to make you understand in simple word, I'll be repeating the same. This beam is an overhanging beam, as you have studied in solid mechanics. Do you remember the solid mechanics? How many of you remember solid mechanics? Overhanging or cantilever, what you can say? Can you remember?
না স্যার মনে নেই,
মনে নেই?
খুব ভালো করে পড়া হয়নি।
Okay, there are types of beam, like it is very necessary while you are talking, while you was in design only. So there are types of beam: cantilever, overhanging, simply supported. So what happens is that this beam is supported, or this beam is attached. This is one type of beam, what we say in terms of analysis. So this part is attached to this part connects this, as you can see in the mouse, as I am rotating my mouse, this part is the part which attach engine to the wings to engine. So this is the attachment area. So what happens is that if there is a certain type of vibration, as you can see, there's a vibration. So what it does is that when this engine vibrates, this beam is also vibrating. Yes or no? This beam is also vibrating. Beam is also vibrating. So since this beam is also vibrating, this wing structure is also vibrating. This vibration is put over there. So what will happen if the vibration is over the limit? What will happen there? If the internal cracks, there are internal cracks. You cannot say that it's a complete homogeneous material, there is no cracks. There are some internal cracks. The internal cracks can propagate. Is that clear to you people? Is that বোঝা গেছে?
Yes, sir.
Okay, fine. Now this is what I want to show you. Now what I will be showing you right now is that how it actually occurs, and how we mathematically we derive it, and what are the way out to understand it. Okay, fine. Now there is a beam, as you can see. A beam is getting it is a shaft, or I'll say rather the shaft gets bent over at the top, as well as the down. So what is happening is that while rotating, the thing changes, and hence there is a graph generated, like the graph is generated. So this gives a amount of explanation why it happens, and how it happens, how it just a sec, I think someone has joined. So what we can do is, we have to understand about one more factor. The factor is stress concentration. Now I spoke about it in the previous class. How many of you remember this one? Stress concentration and factor of safety. Do everyone remember that part? Okay, fine. Now the segregation comes. Factor of safety deals about the material and material property, mechanical property. Stress concentration deals according to the your geometry. How is the geometry? Is the geometry is having a circular cross section? Does it have a fillet, or it is a complete plain structure. So there is a way out how you can understand the structure. Now you may ask me, sir, the structure, the design of a car, one car like Maruti 800 is far beyond, far different from Lamborghini. Yes or wrong? Yes or no? Right or wrong? Am I right? Now, how they can come to a common point? Yes, they have something in common. So we'll be getting those things in a simpler way, which will give us an idea why there are some object which is having a similar of holes, similar type of stress and stress concentration, and which gives us a clear understand how stress concentration can flow from one point to another point. Now, before extending on the going further, let me give you one more example. Like, have you seen the few of the vehicles, like in the car windshield? That is the do you know what is windshield? Everyone, do you know what is windshield? Windshield কাকে বলে সেটা জানো কি? হ্যাঁ, গাড়ির উইন্ডশিল্ড মানে সামনের কাঁচ, বাংলায় বলে সামনের কাঁচটা, ঠিক আছে? Now, have you observed sometime in auto, in car, in buses, the windshield is having a screw. In middle there is a screw, or have you seen that? তোমরা দেখেছো কি জিনিসটা? দেখোনি? না,
মধ্যিখানে স্ক্রু তো দেখিনি।
কি দেখোনি?
অটোতে দেখেছি।
অটোতে দেখেছো, কারেক্ট। অটোতে দেখেছো, most yes, correct. You can see this in auto. This why they have done this? They have done intentionally? Is there any other way for something? Have you thought about it? Why it has been done? Any explanation from you people? Any explanation?
যদি ফুটো যদি করে একটা পিন ঢুকিয়ে থাকে, তাহলে তো ওর আশেপাশে তো স্ট্রেস বেশি অ্যাকিউমুলেট হবে।
একদমই না।
যে অ্যাঙ্গেলে বসানো হয় এটা একটু স্টিপ।
না, এটা একটু অন্য কিছু আছে। Now I'll be giving you the perfect answer for that. Now that will make you to understand why stress concentration and it makes a difference. Now suppose I'm giving you one explanation, the actual application. Let this be the windshield of a car. So you have a crack like this. You have a crack like this. You have a crack like this. Fine. So you could see that the crack has starting point. This is the starting point. I'll be writing in other color that will make this is the starting point, and this is the and the crack is propagating on this way. Now, do you love to have the crack to propagate more, or you want to stop this crack from propagation, from increasing? Would you like to have more? You want to stop over here, correct? So that means why it is happening, because the basic explanation is that this windshield is supported by in every way, this way, this way, this way, and this way. So they are supported in all the ways. That may be by the corner bolt, or that may be by any other structure. They are supported. What happens is that there is a force applied over here, there is a force applied over here, there is a force applied over here. What happens is that due to the force, or due to the force applied, due to the attachment, how it is attached, so this stress is a tendency to propagate. So what we do is that we make a small hole. We make a small hole by using a drill over here. This is the harsh reality. You don't, most of you may know that we make a certain small hole. You may ask, why, sir, that is a hole? Why not other thing? Why you are making a hole intentionally? Is it mandatory to do that? Yes, it is mandatory to do that. Rather, this crack will propagate from this way, this way, this way, this way, and the complete windshield will come to windshield will break. Now, what happens is that, try to understand in this manner. This may be a hole. I'm magnifying it. Actually, I'm very much magnifying this. I'm magnifying this portion. I'm magnifying this portion. So when we make a hole and there is a crack. Crack is nothing but a small opening. There is a small opening. Fine. Can you see the opening?
Yes, sir.
This is the what happens when you magnify it. That means what happens that the stress line, that means the stress get distributed on this complete entire curve. Is that clear? Why do we make hole? Why do we intentionally make hole? Because this entire curve, entire stress stress is transferred to this curve. Is that clear to you?
মানে স্ট্রেসটা ডিস্ট্রিবিউটেড হয়ে যায়, তাই তো?
এক্স্যাক্টলি স্ট্রেসটা ডিস্ট্রিবিউট হয়ে যায়। এক্স্যাক্টলি সেই কথাটাই ক্লিয়ার হচ্ছে ব্যাপারটা তোমাদের, যে এই স্ট্রেসটা আর কোনো রকম ভাবে, এই যে ক্র্যাকটা হচ্ছে, ক্র্যাকটা আর কোনোভাবেই প্রপোগেট করবে না ডিউ টু স্ট্রেস, বিকজ স্ট্রেস গেট ইকুয়ালি ডিস্ট্রিবিউটেড ইন দ্য সার্কেল। ইজ দ্যাট ক্লিয়ার?
ইয়েস স্যার।
Okay, now that's why we make holes and we put a nut or a bolt such that we don't put any other forces and it breaks off. So this is why we do that. Fine. So next is that why is it very necessary to understand? So we have to understand this phenomenon occurs. This all occurs not due to static force. Remember that this doesn't happen due to static force. It happens due to fluctuating force, which actually makes the changes. Fine. Now let us go back to our point. Now I hope everyone understand what is stress concentration. বোঝা গেছে stress concentration কাকে বলে? বুঝতে পেরেছো তোমরা? Stress concentration nothing but the stress distribution in two one dimension, two dimension or three dimension, anything. That
So concentration of stress field in a particular region, এটা বলতে পারবো?
correct, বলতে পারো। Concentration of stress, how much is the stress in area, how much is stress in this area, so you can do that. Correct, you can say that. Now what is the main reason? As I have told you. Now see the first is the slide visible to you people? Is this slide visible to you people?
Yes, sir.
Okay. Now let me get my okay. Now since I have told you that abrupt change in cross section, that means the shape, this number one point actually explains that how much shape is responsible for stress concentration. That means if there is a change in shape, there is a shape which goes beyond there is a shape which goes beyond the limit. So this all makes the changes. So this is what that means, that the cross section is very much, that means the geometry plays an important role for stress concentration. Now poor surface finish. If the surface finish is irregular, that means if it is not polished, if it is having a non-linear, or you may say that it's not the surface is having mountain-like structures, or the surface is having any other problem, so that will also affect. So this one is, and third one is localizing load. That means the internal residual stress. You have to know about these things. Internal residual stress. How many of you know about internal residual stress? Do you know what is internal residual stress? Residual stress? হ্যাঁ, কোথায় কোথায় পড়েছিল রেসিডুয়াল স্ট্রেস? রেসিডুয়াল
শোনা শোনা লাগছে, শোনা শোনা লাগছে।
We have studied residual stress in welding. In the previous session, BTech, I have taught for the BSc student. I have taught you about the thing. If I give a bit of it. What does residual stress mean? The residual stress means the stress between the boundary layers, which we observe while recrystallization. After recrystallization, the stress, there are some there may be internal, that is completely internal, you cannot observe from the outside. So there are internal tensile or compressive stress, which is termed as your residual stresses. So this is what does that means. Now localized loading, that means this can also affect. And now third is the material property. What type of material is this? But it hardly matters. Let me tell you, it hardly matters. That doesn't matter so much. It matters, but it's the percentage is very, very less. Fine. What reducing stress, you could reduce the stress concentration. That means you, in other words, how can you can minimize the stress concentration? It is by it is by applying notches. That is nothing but notches is something like making a fillet or chamfer. I'll show you in design today. Next is making additional holes, drilling holes, as I have showed you right now, as that's what is done in the auto or car. So third is the fillet radius, as I have told you. Now by threaded members, by concentration through threaded members, this is all goes to directly to the circular objects. Now we also avoid taper or sharp corners, because sharp corners increases stress concentration. Fine. Now while I was talking about it, I have something for you to understand, that there are two types. This will be the last theory topic, then I will go for the practical ones. Now this is termed as your fluctuating stress, and this is termed as your fatigue stress. Now as I have told you, this is very easy because you can understand, but let me tell you, is it written over here? It is, you can see and you can learn also, but this is not the way. Why? Because you have to know what is fluctuating stress. Fluctuating stress is irregular static loading only. It's a static load only under a certain cycle. That means the static load could differ. Which generates more devastated fatigue rather than your fluctuating load. So what happens is that this is when a static load is applied with phase to phase, that is time to time, in a certain motion. Then we say in a cyclic manner, then we say that it's a fluctuating stress. Fatigue failure, there are three types of fatigue failure. That is, one is due to fluctuating stress, next one is the repeated stress, third one is the reverse stress. Okay, I'll give you everyone a simple example on the next day, but I'll give you one way out how you can understand. Fluctuating stress means there's a irregularities on the stresses, and which makes the problem. And repeated stress means it's something like the stress you apply, you remove it, apply, remove it, apply, remove it. So this is what repeated stress means. And reverse means when you apply negative stress, that means compressive and tensile stress both are acting one after another, then we say that then it is a reverse stress. Is that clear? I have just given you a brief idea. Is that clear to you? Is that clear?
Yes, sir.
Okay.
Yes, sir.
Okay, fine. Let us go back to the next to our software one. Now today I'll be showing you about regarding your how software works and what are the way out we work in software, and how to understand that this create something and how to make it very easy for you people. Now let us get back to my board. Okay, fine. How many of you have registered? I just want to know how many of you have registered. How many of you have registered?
Sir, I have registered, sir.
So have you sent me the mail? Have you sent me your mail ID?
Sir, in the WhatsApp group?
Yes, just send me over there your mail ID. The persons who have registered, I don't need the BSc one. I have the BSc one people, but those who are not BSc, BTech people, please send me. Okay, fine. The mail ID you have used to register in this website. Now, okay, so this is what OnShape looks like. So at first you have to know what is sketch, how you can do the sketch, and what are the way out to do, what we have in sketch. Then only we go for making them in solid, how to make solid, how to make in other words, have you how to
স্যার বলছি যখন আপনি এগুলো শেখাবেন মানে কি করে ড্র ফ্র করতে হয়, তখন কি মানে আমরা সাথে সাথে করবো সেইভাবে শেখাবেন নাকি আপনি শেখাবেন তারপরে বাড়িতে আমরা করে গিয়ে জমা দেবো
আমি
এইভাবে?
কারণ কি তোমরা সাথে সাথে করতে গেলে তোমাদের ক্লাস টাইমিংটা আমার বাড়াতে হবে। দ্বিতীয় কথা, আমি তোমাদের এররটা আমি তো দেখে বলতে পারছি না তোমরা কোথায় এরর করছো। তো বেস্ট আমার হিসাবে বেস্ট এটা যে আমি করে দিচ্ছি, তোমরা করে আমাকে বলে দাও যে স্যার আমি এখানে আটকে গেছি, তখন আমি আবার করে তোমাদেরকে বলে দেবো যে করে বলতে আমি দেখিয়ে দেবো যে এই পয়েন্টে এটা চেঞ্জ করলে এটাকে এভাবে ইয়ে করলে হয়ে যাবে। আমি এই জিনিসটা তোমাদেরকে করবো যেটা আমি আগেও করে এসেছি, ঠিক আছে। এখন যদি এটা প্র্যাকটিক্যাল ক্লাস হতো তাহলে আমি এটা বলতে পারতাম যে ওকে ফাইন, তো এইখানে আমি তোমার হাতে ধরিয়ে সেটা বলে দিতে পারতাম। কথাটা বুঝতে পেরেছো?
হ্যাঁ, মানে সেভাবে সুবিধা হতো আর কি, সেই জন্য। যাই হোক, ঠিক আছে।
কে এসেছে? Okay. Now let us consider a section like this. Let us consider this one, or let us consider sketch first. Let me show you something about sketch, then only I will go. Okay, while sketch you can see that there are views like top, front, right. So what you can do is that you could select any of them, and you could change your view from front, you could change your view to any other like top. You could view to right. So there are a lot of ways how you can do that. Now there is one way out to understand. Let me tell you one more thing what you need to know about it, that how can you understand in which plane you are working or you are making the sketch. There are something which you need to which will make you to understand that this you are working on the sketch one. There are there should be something which makes you understand that there should be some symbols. Though the symbol is the way you have to observe. That is, as you can see, it is written as sketch 1. Now you will see that here it is also written sketch 1. That means you are working on sketch 1. So sketch 1 is on the plane of front. As you can see, it is on the plane of front. On the plane which is in the front. front plane. Now you could now how to do that? Now for making a sketch, what you need to is that you need to select or click on the sketch and select the plane where you want to draw. Let me select the top plane. Fine. This now you can see in the top plane is superimposed by another plane that is named as sketch 1. Am I clear to you people? Am I clear?
টপ প্লেনটা কি ডিটেল জিওমেট্রিতে গিয়ে সিলেক্ট করলেন তো আপনি?
হ্যাঁ, আমি আবার দেখাচ্ছি। স্কেচ সিলেক্ট করলাম, ঠিক আছে? স্কেচ সিলেক্ট করে এই টপ প্লেনটাকে সিলেক্ট করলাম। আমি জিওমেট্রি কিছু করিনি, শুধু প্লেন সিলেক্ট করছি, ঠিক আছে? সিলেক্ট করলাম।
কই কোথা থেকে? আচ্ছা আচ্ছা, এই ডায়াগ্রামে করছি।
Exactly. I can do in other way around also. Let me show you the other way to do. If you don't understand this way, there may be a confusion, because we have a limitation to we get confused most of the time. So there's a one way better way also to understand. Go for sketch, select plane. You could directly select the plane from here. If you select the top plane, see, this plane has been selected. Is that clear?
স্যার বলছি ওই যে পাশে যেটা ওই স্কোয়ারের মধ্যে টপ ফ্রন্ট লেখা আছে, ওখানে গিয়ে যদি আমি টাচ করি তাহলে
এটা কথা বলছো? না, এটা জাস্ট তোমাদেরকে বলে দেবে যে হ্যাঁ, এটা তুমি এটা দিয়েও আরেকটা আমি দেখাচ্ছি, এটা দিয়েও করা যেতে পারে, বাট এটা দিয়ে তুমি ডিরেক্ট ক্লিক করলে এটা হবে না। এটা জাস্ট তোমাদেরকে ভিউটা দিতে সাহায্য করে। ইট জাস্ট শোজ ইউ হাউ ইউ ক্যান সি দ্য ম্যাটার। It just show you like this. If I change it, if I
আমি ওটাই বলছিলাম ওই যে আমি টপটা সিলেক্ট করলেন, আমি ফ্রন্টে টপ এসে গেল, তারপরে আমি কিছু চেঞ্জ করতেই পারি।
Exactly, you can change it. Now what you can do is, let me show you in another manner, as she told that let me tell you that she was speaking about. Now what you can do is that one more method is there. Now it's not a method actually, so this is some way. There are lots of ways. Other than that, there are many of the ways. Select sketch. Now what you can do is either select a top, or if you are not getting where is the top, you cannot see the top. So what you can do is you can rotate it and you can find top. Click on the top and select the top plane. You can do this also. So you have lot of redundancy to do these things. Now in which plane you are drawing, in which plane you are walking, the easiest choice is just see this one, sketch 1. Is it visible to you people? Is it visible?
Yes sir.
So this gives an idea that which one is sketch 1 and where you are drawing. Okay, fine. So at first you need to understand there are only one type of line. There are two type of rectangle. One is corner rectangle, one is center point rectangle. There are three types of circle. One is circle with point center point circle, 3-point circle, and the another one is ellipse.
3-point circle কি?
3-point circle মানে তিনটে পয়েন্ট ধরে সার্কেল ড্রয়িং করা। ঠিক আছে, আমি আসিনি, আমি একটা করে সবকটাই দেখাবো, কিছু ডেসক্রাইব করবো। আমি আগে তোমাদের পরিচয় করিয়ে দিই। আমরা যেরকম কারোর কোথাও গেলে আমরা বলি না যে এই হয়েছে কি আমার এর ভাই, এর বোন, এরকমভাবে বলি না, তো এই জিনিসটা আমরা পরিচয় করে দিচ্ছি। So next is your arc. Arc can be by these 4 types. There are polygons of 2 types. There is this spline of 2 types. There is a point which you can select. There is a letter writing. You can do direct the letter writing what you have done in your first year. What you have done in a first year. This type of letter writing you can do over here, and directly you don't need to do anything. You don't need to worry about it. Next is your next is your project converter. That is other thing that where we convert a localized thing to a solid. So this is something we'll go afterwards, and where we consider the intersections also. Now fine, next it is termed as fillet. Fine, it is termed as fillet. There are trim, there are extend, there are split. there are offset and slot, there are mirror, there are types of array or pattern, there are other than that there are, just a minute, there are images which you can bring, there are something, there are lots of dimension, and this one is the relations what you can give. Fine. It is the it is how you can get to know. Now let us start with one thing. Now what you can do is that you can click on the line, then if you draw a line, you can see that how you can understand this is the line is horizontal. Now what happens is that in AutoCAD we have two options, that is one is termed as ortho, and where you can either turn on the ortho, which will give you either horizontal or vertical line. But here you don't have these things. In this software you don't have these things. In advanced softwares, like in most of the advanced softwares which is used in industries, we don't have this ortho or OSNAP. It is by default, it is given by default, and it is in hybrid mode. Fine. What does that means? That means they will allow you to use ortho in every way you go. That means it will give you a path how to understand. Now how? Let me show you. Now can you see a single minus sign appears? Can you see a single minus sign? Is it visible to you people?
Yes, sir.
That means that this line is a horizontal line, is a purely horizontal line, 0 to 180 degree. Is that clear?
Okay.
Now if I come with this one, now this shows a vertical line. Now see, again a L, this shows a horizontal line. Now you could also do an angled line. This gives you a redundancy where you can draw, you have this, you could put relationships and everything. Now this is what is the basic things. First you have to understand. Now what happens is that when you release it, you may see that there is a number coming on 236, 214. As you can see, this is the length which is showing. This is the real time length showing. So what you can do, you can click over here. This will give you, so this is what lines looks like. Now next is, if you draw another line, let it be anything, but if you want to eliminate any line, try to understand, if you want to eliminate any of the line or you could just, what you can do is you could select one line and press delete. Clear? Till now is it clear?
Yes, sir.
Now next, if you want to eliminate a few lines, not entire line, or suppose you want to eliminate the lower portion of this one, but you want to keep the upper portion. So what you need to do, you have to use scissor. The name of the scissor is trim, TRIM, trim. What you can see, as you can see scissor icon, how can you understand which icon is what? If when you bring your mouse over there, you don't have to click it, you just hover on it, it will show the trim, and it will show how it works. As you can see, as I bring on the trim, it shows that select trim tool, click on the curve you want to trim. So simple, it is showing the 2-step only. You have to first select it. Let me select it. Fine. Then after, just bring on the line you want to eliminate. I want to eliminate this line and I want to eliminate this line. See, I am left out with this line. Is that clear? Is that clear?
Yes, sir. Yes, sir.
Okay, then আবার দেখাচ্ছি। ট্রিমটা সিলেক্ট করলে, ঠিক আছে, তুমি এটাকে ক্লিক করলে, জাস্ট ক্লিক করলে তোমার এনে এটাকে সিলেক্ট করে এটাকে এনে দিয়ে কোনো রকম এটাকে মাউসকে ধরে রাখতে হবে না, কোনো কিছু না। এইখানে ক্লিক করলে আর এই জায়গাতে ক্লিক করলে দেখো দুটো এলিমিনেট হয়ে গেল, দেখা যাচ্ছে?
বলছি এই ফাংশনটা দিয়ে লাইনস গুলো ওই পয়েন্ট অফ ইন্টারসেকশনের অ্যারাউন্ডে এলিমিনেট হলো, কিন্তু আমি যদি মানে অন্য কোনো ডিজাইরড লেন্থ অফ এ লাইন এলিমিনেট করতে চাই, তার কোনো ফাংশন আছে কি?
মানে আমি কথাটা তোমার বুঝলাম না ঠিক।
স্যার একবার আন্ডু করুন পুরো জিনিসটা।
করে দিলাম।
হ্যাঁ, এই যে এই দুটো লাইন একটা পয়েন্ট অফ ইন্টারসেকশনে কাট করেছে তো।
হ্যাঁ
হ্যাঁ, তো এই ট্রিম ফাংশনটা দিয়ে আপনি যখন ডিলিট করছেন, তো এই পয়েন্টের থেকে মানে যে লাইনগুলো এক্সট্রা আছে সেই লাইনটা পুরোটা ডিলিট হয়ে যাচ্ছে।
হুম
তো আমি বলছি যে ধরুন আমি এই পয়েন্ট থেকে ডিলিট করব না, বা অন্য কোনো রেস্ট অফ দ্য পোর্শন যদি আমি ডিলিট করতে চাই লাইনটার, সেটার কোনো ফাংশন আছে কি?
এটাকে করার, ডিলিট না করে এটাকে এরকম তোমার একটা ফাংশন না, একটা সিস্টেম আছে, আমি জাস্ট দেখিয়েছি। তুমি লাইনটাকে ছোট করতে পারবে।
ও আচ্ছা, তাহলে ঠিক আছে। হ্যাঁ,
ডিলিট করার দরকার হয় না, ছোট করতে পারো। অথবা
ওকে।
এটা একটা আরেকটা উপায় দেখাচ্ছি, এটা একটা উপায় এইভাবে জাস্ট what he told is that you could if as you can see the by trimming the entire line from the intersection point gets deleted, but he asked me if I need to eliminate up to this one, I need to keep this one, what to do? The same, there are two way out. What you can do is that bring this to this one, this line, just select the point, select this head and bring, just call to this line. Now how can you now there's a point, how can you understand that you are hitting on this line or you are intersecting? Just see that a dash line is appearing. Can you see a minus sign?
Yes, sir.
So that means it is the point is on the horizontal axis. Clear?
Okay, yes, sir.
Now if you want to change the dimension, let me come to the point. If you want to change the dimension, is there any way out how to change it? Yes. Now what you can do, this is the three most things which is needed while drawing. The other things are least important, but they are important, highly important, but compared to these three things, because these three things is all about drawing in 2D. Now we will not do 2D, we will do 3D, but the thing is that for 2D, we are learning 2D because 3D is not valid when you don't do a 2D cross section. So you have to make a 2D cross section, for which you need to know this commands and everything. So what you can do is you can select on this these dimensions, that means this is the dimension tool. Now what you can do is, let me select this one and this one. Just see, it's very simple to select either. Now see, it is written that 26.899 mm. What you can do is you could change it by writing 30. Simple, you don't need to do anything. Is that clear?
Yes, sir.
Now let me show other things also. Now you have a confusion that you don't suppose you have forgot the calculation, that it would be, that means you forgot the number, but you remember that it is 38 plus 2 into something, so something. So what I know that it is 38 plus 1, just a sec. Okay, I know this 38 plus 1 and plus under bracket 2 divided by 2, enter. How much should be the value? 40. See, you could see 40. Now why I have done this way? I have done this way to show you that the mathematical calculation, for mathematical calculation also, you don't have to worry that oh my god, I don't know the mathematical calculation, or I have to do the mathematical calculation by using a calculator. No, you don't have to worry about it. You could directly input the mathematical calculation over here. Is that clear? Like, let me show you one more example. This point to the center, how much it shows? 147. So if you need to make it to 150, what you can do? 147 plus 3. ক্লিয়ার? সবাই বুঝতে পারছো ব্যাপারটা? বোঝা?
Yes, sir. Yes, sir.
So there is a one way. You could also change the angle. So since I have given the value, it will not change. I have to remove the value. Let me show you this. To remove this, I have to remove this. Okay. Let me bring this one and this one. See, this is showing 23.65. Even this work from over here also. 35, 30 plus 5. Enter. Is it clear to you people?
স্যার এইটা
আরেকটা কি করে করলেন স্যার একবার দেখুন
এই ডিগ্রিটা একবার বলুন,
ডিগ্রিটা আমি কি করলাম? ওকে,
মানে কি করে আনলেন?
okay, select, click on the dimension, click on this line, click on this line, the next line which you want. Now this now see it is now it is you can see when it will show angle and when it will show the distance. How can you can understand if it is showing like this? See, if it is showing with degree, that as you can see 23.65 something, this is showing degree. As you can see, what you can do, click on that one, write 30 plus 5, press enter. That's it. It's very easy for this. Okay, now one thing come to your brain, that's then what type of value what type of formulation it is. It is according to it. It is according to BODMAS rule. BODMAS. What does that means? Bracket, division, multiplication, plus minus. So this it follows that rules. That means it will do anything which comes in bracket first, then it will divide, then it will do anything other than that. Fine. So is that clear till now? Is that clear?
yes sir.
Now I'll show you the last thing of today's class, which may blow up most of you. May think that is the advanced software is feasible to do these things, but most of like AutoCAD is not feasible. For that you have to make some certain changes, then only you can see the feasibility. Now what you can do is select this point and select this point. Let me get the dimension. It shows that it is 30 degree, 30. Fine. Now 30 mm. If I have my calculation in centimeter, but I have to get it in millimeter. So what I did is I have changed the setting of the software in millimeter, but I'll give the input in centimeter. You got my point? Is it clear to people?
Yes, sir.
That means the software is, I have set the software in millimeter, but I'll give the input in centimeter or in inch. Fine. I'll give at inch at first and I'll show, then I'll give in centimeter. I'll show you. Now let me give 1 in inch. Press enter. 25.4 millimeter. Is that clear? That it will automatically change its dimension to millimeter. Clear? Similar goes for you could write 25. So you could write 3.5 centimeter. Press enter. See, it is showing 35 millimeter.
সেই যে লেখাটা আছে সেটাকে একটু বাঁদিকে শিফট করানো যায় কি, মানে একবার সেট করার পরে?
মানে কোথায় শিফট করতে? বাঁদিকে? হ্যাঁ
আচ্ছা আচ্ছা, দূরে ওটা ঠিক আছে।
হ্যাঁ, বাট দুটো ডাইমেনশন লাইন ক্রস করানোটা উচিত নয়, ঠিক আছে? এর জন্য শিফট করলেও আমরা এদিকে আমি চাই, এটা রুল বলে যে শিফট করানোটা উচিত না, এর জন্য আমি শিফট করাই না। কথাটা বোঝা গেছে? আমি এটা রুল আইএসও রুল হিসেবে শিফট কোনো ডাইমেনশন লাইন কোনো সময় আরেকটা ডাইমেনশন লাইনকে ক্রস করানো দরকার, মানে চেষ্টা করা দিয়ে না ক্রস করা। যদি না পারা যায় তাহলে তো করবেই, ঠিক আছে? So this is all about of today's class, and we will be getting the next classes by we'll be doing going for the next classes by next week. So till now, if you have any sort of any sort of confusion, just let me know. এনি কনফিউশন, কোনো কনফিউশন থাকলে বলতে পারো যে এইখানে স্যার এটা বুঝিনি, এইখানে এটা বুঝিনি, কোনো কনফিউশন থাকলে বলো, আমি এই ডাউটটা ক্লিয়ার করে দিচ্ছি। এখন জাস্ট ডাউট ক্লিয়ারিং সেশন। কোনো ডাউট আছে? কোনো ডাউট? কেন কথা কথা আসছে না কেন? কোনো ডাউট আছে কি?
না স্যার।
আচ্ছা, সফটওয়্যারটা কি ইজি না হার্ড? আমি তোমাদের কাছে জানতে চাইছি সফটওয়্যারটা কি ইজি না হার্ড?
স্যার আপনি হ্যাঁ অনসেট তো ইজি, মানে এখন আমাদের সব স্যারেরা অনেক কিছু ডাউনলোড করতে বলছেন, অনসেট ওর থেকে বেটার, মানে মেটেরিয়াল স্টুডিও বা ম্যাটল্যাব গুলো সব ইনস্টল করতে অনেক প্রবলেম হচ্ছে।
কারেক্ট, আমি হ্যাঁ, বাট ম্যাটল্যাব ইজ সামথিং আদার দেন দ্যাট, ম্যাটেরিয়াল স্টুডিওটা আলাদা, বাট দ্য থিং ইজ দ্যাট ম্যাটল্যাবটা তো বেসিক্যালি ম্যাথামেটিক্যাল টুলস নিয়ে কাজ করে। অনশেপ ইজ ভেরি ইজি প্ল্যাটফর্ম ফর এভরিওয়ান, but the thing is that you have to also know about MATLAB and Material Studio এত একটা আমাদের মানে এখান থেকে আমরা শুধু ডেটাটা নিয়ে ইয়েতে দিই, সফটওয়্যারগুলো দিই, যেমন যেমন আমাদের সলিড ওয়ার্কস আছে, অনশেপে অনেক সময় ম্যাটেরিয়াল চুজ করতে গেলে আমরা জিনিসটা দিতে পারি। ঠিক আছে না, এই আমরা কি করব নেক্সট ক্লাসে আমরা ড্রয়িং করব। ড্রয়িংটার মধ্যে আমরা প্রত্যেকটা টুল নিয়ে ড্রয়িং করব। টুল নিয়ে ড্রয়িং করে আমরা শিখবো যে কোনটা কি করা যেতে পারে। না, আমি ক্লাসে যা পড়াচ্ছি আমি রেকর্ড দাঁড়াও, আমি তোমাদের সঙ্গে তোমাদের অ্যাটেন্ডেন্সটা নিয়ে নিই, নিয়ে তারপর কথা বলছি। অ্যাটেন্ডেন্সটা নিয়ে নিচ্ছি, দাঁড়াও।